YouTube saying we're live. G'day, Simon. How are you, mate? Welcome to the
Hello,
Handcrafted
mate.
by Terry G channel. Yeah, yeah, there's a few on at the moment, so we'll give a few shout outs, mate. G'day to Steve W, Jamie Fulton, Tim Ryan, Mark Lavelle. G'day, mate. Robin Green's on. G'day, Robin. Hope you all had a fantastic Christmas, and especially with all your loved ones and friends. And welcome, Simon, to the Handcrafted by Terry G channel, mate. And just tell the viewers at home, mate, a bit about yourself that don't know you.
Oh, g'day, Terry, and thanks for the invite. Much appreciated, mate. Always like to be on other people's streaming, especially talking rubbish about things that I'm into, like 3D printing and four-wheel driving, camping, etc. Look, not a lot to tell about myself. If you haven't seen my YouTube channel, it's Lock Your Hubs Four-Wheel Driving. Smaller YouTube channel, and we do odd little things and bits and pieces like blow up tyres for the nitrogen, which is always good for a laugh. I haven't done a lot of 3D printing on the channel, though. I do. I mainly do technology related things, not actually a lot of four-wheel drive trips. It's all four-wheel drive and adventure related type content. There's electronics, there's mechanics. We do a few tutorials, like if you want to learn how to fix up the front end of your Land Cruiser or the rear end of your Land Cruiser and rebuild the knuckles up the front or things like that. We've done a few bits and pieces like that. And look, it's just about getting out there and having a bit of fun. So that's what the YouTube channel's about. So like I said, it's only a small one. I think it's got 25,000 subscribers or thereabouts. So, it's a good bit of fun.
Good bit of fun, yeah. And now, mate, you're right into 3D printing.
I am.
Tell us a little bit about that.
Well, the missus hates it for starters. Especially when I turn on the extraction fans and smell out the house. Look, I've been doing mechanical and engineering type stuff for very many years. I've done a lot of metal fabrication and bits and pieces, and this is just an extension of that, really. I got firstly into doing resin printing, and now I've gotten into the FDM stuff. You can probably see in the screen behind me a couple of FDM printers, and off to my right hand side is a resin printing setup.
Right.
And look, I mainly do mechanical type things, functional prints. As opposed to models and stuff. And look, I still do a few little models here and there and toys and whatnot, but primarily focus on functional stuff.
On functional stuff. So, Simon, how does a 3D printer, mate, actually work, especially with filament printers and resin printers, mate?
Okay, so there's for those who aren't aware, and I'm sorry if you already know this, there's two main camps. There's the FDM style printers, which use thermoplastics, and then there's the resin printers, which use photopolymers. Now, FDM is, everyone would have probably heard of an Ender 3 or a bamboo printer, and they're all FDM printers. And usually what they do is they take a thermoplastic, and thermoplastic's just a plastic that melts at a certain temperature, depending on the type of plastic it is. And then you get an orifice or a nozzle on the end of the printer, and it squirts it through that orifice, might be 0.4 millimeters, and then does it in a various shape and keeps on putting layers on top of layers on top of layers until you've got an object, something like this or whatever you're printing.
Yeah. So how strong are the 3D parts, mate? Especially the strength of the 3D, so are they fairly durable, mate?
Yeah, so look, it depends on the type of printing. So you get FDM and you also get resin printers. Now, resin printers are a different kettle of fish. They're a bit more labor intensive, but the quality of the part is a fair bit better. But sometimes it's not so economically viable to make stuff with resin printing. Depends on what you're making. Right. If you're worried about economics and functional parts, you're probably going to look at FDM. If you're looking at things to, especially models, if you're into D&D or Warhammer or those sort of things, resin will be your bag. So that takes a resin in a vat, literally a liquid, like a thick gelatinous liquid, and then shines either a laser or a light into it, depending on the process. And then a UV light, and then cures it, and then builds it up layer upon layer upon layer, like FDM, but it builds it bottom down instead of top up. Sorry, top up instead of bottom down.
So it's very much like the laser engraver that I got, where it actually burns the image into the timber, but this one it actually draws, doesn't it, with the FDM and runs around, and it just builds up by layer.
Yeah. So the resin printing, the SLA, which is stereolithography, that actually is sort of similar to your laser engraver, in that it shines the laser onto the build plate and does a very thin layer of cured resin, and then drags that one off and then goes for the next one.
And goes through the next stage, right? Yeah. So what type of filaments and resins is there, mate?
Again, it depends on your use case. So I tend to do a lot of engineering filaments. Probably the most common one you'll hear is PLA, and that's actually a naturally dried one. I think it's made out of corn. I could be corrected on that one. Maybe someone might want to correct me in the comment section. But it's an organically derived one, and it's good for models and stuff that's going to stain. So it's actually fairly strong. Not great if you're building stuff for your car, because a hot car, even in Melbourne down here, and especially up where you are in Queensland, it'll warp and melt. So you need a better quality filament. Now, usually a lot of manufacturers use ABS, which is very common on cars, bumpers and whatnot. And a sort of an evolution of ABS is what's called ASA, which is very, very close to ABS. And I tend to use a lot of that for the functional prints. It suffers a little less from warping, and it's a little more heat resistant and a little bit more printer friendly than ABS.
Yeah. So what is ABS, mate?
Sorry?
What is ABS?
Oh, geez, I forget. They're all acronyms, of course. I believe the S is for styrene, and that's the one you need to worry about. So that it creates, and I think we'll look at it a bit later, bad things in the air that you don't want to be breathing in.
Right. So is that all type of elements and stuff like that? Is it very toxic? All of them?
So what you're looking for is the amount of VOCs or volatile organic compounds that they produce. So the likes of ABS create a fair bit, and it stinks to high heaven when you're printing that stuff. ASA is not quite so bad. PLA is pretty good, to be honest.
Pretty safe. So how does someone as a beginner get into 3D printing, mate?
Well, again, it'll depend on what you want to be printing as to what type of printing you'd want to do. If you're into Warhammer figurines or whatever, you'd probably be looking at a smaller resin printer, and they're very economical. Pick one up for a couple $100. Or if you're more into the functional stuff, or you want to make larger stuff, you'd have a look at the FDM printers. And there we go. It's been considering a bamboo printer. Now, the other thing to consider around that sort of stuff is, do you want to get another hobby, or do you just want to make stuff?
Yeah.
Now,
and I suppose that's the big question, isn't it? Yeah.
Yeah, it can be either. So if you get into something like a rat rig or a Voron type setup, that you're making yourself another hobby. Right? So it's an additional hobby on top of your other stuff. Whereas something like the bamboo printer that Australian Camping and Four-Wheel Drive has mentioned, they're more of an appliance. I do with my bamboo printers. I do very little work to them. One of them's got near 5,000 hours on it now, and I've done next to nothing on it.
Next to nothing.
It just keeps cranking out those parts.
Those parts. Yeah. So what's the difference between a filament printer and a resin printer, and what would you use them for?
Yeah, so as I was saying before, the resin one is high detail, or if you need precise parts, if you need a precise surface or something like that. Let's say you're making components to electroplate, and you can electroplate over plastic, of course. You'd probably be looking at you'd be looking at things like a resin printer. But if you want just a functional part, if you want to create an Anderson plug mount like this one is, well then you'd just use FDM because it's good enough.
FDM, yeah. Hey guys, what we might do, we might leave all your questions go to the very, very end, and what we'll do is I'll actually bring up a link to come on, and you're quite welcome to jump on into our StreamYard and meet Simon face to face, or you can ask the questions at the very, very end of the stream. So I'll just go through a few more questions, and then we'll ask you guys at home if there's any questions that you'd like to ask Simon, and he can answer them. You can jump on and meet Simon and go from there. So we'll keep going, Simon. So our next question is, what is the safety caution should we take before printing with filament printers and resin printing?
Like I was saying before, it's the volatile organic compounds, or the VOCs. Yeah. And it is dependent on the type of printer, but it's a good idea to run a negative pressure. And that, what I mean by that is you have an exhaust fan in the room, you can get those bad particles out of the air where you're working. So you probably don't want to put a resin printer with no exhaust fan in your bedroom. It's a bad idea. Especially if you're using an engineering resin, you'll get bloodshot eyes for a couple of days after use it. It's not a good idea.
No. So where do you find stuff, Simon? If you're not very good with technology to create stuff to 3D print, mate.
And look, even if you are, even if you have a good degree of, you're able to use CAD or something similar to that. Right. I always go to websites and see if anyone's created something, either what I'm after or something very similar that'll do the job. If I just want something that does something, if I just want a solution for an issue I'm having, instead of sitting down for hours in front of SolidWorks or whatever, I'll go and have a look. So Thingiverse is probably the best well-known one. That was one of the original ones, and then I think by MakerBot, which was one of the early FDM printers. And then you got Printables, and that's run by Prusa, which is another very famous printer manufacturer. MakerWorld, which is MakerWorld's run by the Bamboo, and it's not as popular as Thingiverse or Printables, but it's not bad. Colts 3D. There's another one. There tends to be a lot of there's quite a few free models, but there's a lot more paid models on Colts 3D. Right. And when you get into designing your own stuff, there's things like GrabCAD, which has a lot of SolidWorks models in there, or other types of formats of models, which you can use in your own models. You can grab part of whatever you're after. And the big one that, if you're into designing your own stuff, is a website called McMaster-Carr. Now, McMaster-Carr is actually a hardware retailer in the States, but what they have is, if you're after, let's say, you want to make an oven. I'll give you an example. So my son found an air compressor, and the problem with the air compressor was the inlet filter had broken off. Now, I had a filter, and I didn't have any way of joining that filter to the head of the air compressor. So instead of sitting down and working out what thread it was, still had to do that, of course, and then designing that thread into the model, I went to this place called McMaster-Carr. I found the thread that I was after, and they have models for all of their bits and pieces. So I just grabbed that model, it was already ready to go, and then just modified that model because it's in SolidWorks, which I use. Yes. And just made the other end to fit the air filter, and Bob's your uncle printed it out. A couple of hours later, he had a working air compressor for nothing.
Yeah. So how do I go, mate, with designing things, and what programs are available out there to download to design those programs, mate?
Yeah. So again, it depends on what you want to design. If you're into organic shapes like your Warhammer and your D&D stuff, probably Blender would be your bet, which is an open source software, so it's run by the community.
Yeah.
and modified by the community. So that's probably your most common for organic models if you want to make little flexy animals and all that sort of gear. If you're into more functional stuff, there's probably two main ones. One's Fusion 360, the other one's SolidWorks. I myself use SolidWorks. That's probably the most it's probably the most common in industry. But I'd say amongst the 3D printers, probably Fusion 360 is the most common, and only because they offer a free tier.
Right.
SolidWorks still offer a near free tier, but you still have to subscribe.
You still got to. Is that also a paid thing that you got to do as well with Fusion 360?
No. Fusion 360 is you can use a free program as long as you're not using it for commercial purposes. No problems.
Right. No problems at all. Right. I see. Yeah. And with the filaments and the resins, mate, what's the actually? How long do you get to do they last with being in the elements, mate? Especially with filament. The 3D for the FDM printers. So how long would a roll last in the elements, mate, before it's no good to use anymore?
That's it's a kind of a it depends answer as well, as most things in this life. So it depends on the atmosphere that it's living in. If you're in a very dry area, 10-20% humidity. The problem with a lot of FDM filaments like PLA, not so much PLA, but definitely your ABS, your TPU, which is the flexible filament, things like that. They absorb moisture from the air. They're what's called hydrophilic. So what you need to make sure is you're getting that moisture out. Now, when it's done commercially in, let's say, a molding process, injection molding, they heat up the plastic prior to it going in and being injected. So if you have issues with your bits and pieces coming out bubbly looking and maybe even they sound like really wet stuff can actually spit water and bubble and boil as it comes out of the printer nozzle. You need to dry your filament. So I've got a filament dryer because I use a lot of engineering filaments, and they're usually the ones that absorb the moisture from the air. So PETG's bad, TPU's bad, nylon is horrendous. You pretty much got to print that stuff out of a dryer, directly out of a dryer into the machine. Otherwise, it'll draw too much moisture from the atmosphere. And then my filament printers have what's called a AMS system on top, which just contains 4 rolls.
Yeah.
And in there, I've got desiccant and lots of it. And I keep track of what the humidity level is inside the AMS, so I know when to change out the desiccant. And also in my storage containers, which you can probably see a couple of them just above my head there. There we go, over there. They've got desiccant in them as well. So when I get a new roll of filament, I always dry it, run it through the dryer. I've got a 4-roll dryer, and then I put it into the storage containers, which are IP rated, so they're sealed storage containers with a big heap of desiccant, and then I don't have issues.
Right. Yeah. So
it's not so much an age thing.
It's what, sorry?
It's not so much an age thing. It's just making sure the stuff's dry.
Stuff is dry, yeah. So say if we got like PLA, how long do you reckon a roll of PLA would last, mate, before it's no good?
Oh, cheers. Look, I've got stuff that's 5 or 6 years old, and I've used that. Old stuff. I don't use a heck of a lot of PLA other than for prototyping, but I had a little bit left over, and I thought, I'll use that up. About 5 or 6 years old, I ran it through the dryer and printed no problems. So, like I say, it's not so much the age of the material with the normal FDM printing stuff. It's just making sure you're keeping in the right conditions.
Just making sure that it's right, yeah. Rob from Australian Camping and Thought, or Dryman's just jumped on. G'day, Rob. Hope you're well, mate. His question is have you had any experience with 3D scanners?
Yes, I have. I have a RevoPoint 3D scanner. Right. It's probably verging on where you're moving from a hobby to something a little bit more serious. The advantage of a 3D scanner, and again, it's horses for courses. It depends on what you want to be scanning as to the type of scanner you get. You can get ones that concentrate on little high figurines that do an excellent job at really small detail, but they'd be hopeless for scanning a car, for instance. They just don't have the detail on flat surfaces. So you have to get the appropriate scanner to the type of thing you want to scan. But the great thing about it is you can then import it creates what's called a mesh into your CAD software, and then you can either if you're replicating a part, for instance, you can scan and then replicate the part in your chosen CAD software, or maybe and this is probably where it comes in more handy, is you've got an original part and you've taken a part off that's not doing the job that you want, but you want a new part and you want to create that part and you want to made it up to an original surface. So you want to grab those bolt holes in space, and you want to be able to create without too much measuring. And you want to create a part that will bolt straight on to the existing part. And that's where 3D scanners come into for. And look, they're like anything. You need to use them. You need to get used to them. You need to, and look, I'm no professional when it comes to 3D scanning. I cannot embarrass myself. But I wouldn't say I'm a professional by any stretch of the imagination. But they're great. They're great, and they're becoming cheaper. Especially with the likes of Creality and whatnot jumping in on the market. I'm sure everyone who's into 3D printers have probably heard of Creality. And they make I've had a Creality printer, an S5, a big old S5 many years ago.
Right.
And look, it's becoming more accessible. It's becoming easier, and it will start being less professional and more hobby based as we move on. And you don't even need a 3D scanner to do 3D scanning. So there's this process called photogrammetry, and what it is you can even use a mobile phone,
right?
And you can take a lot of photos of the thing at a lot of different angles. Up, down, around, right, 30 or 40, maybe 50 photographs of the same little object, and you can put it into some software and you'll be able to generate a 3D model of that object with reasonable accuracy. It's not as fast or as easy as a scanner. So, my scanner for a small object, it takes 10 seconds. Whereas you're using photogrammetry, it's a multiple hour process, but no extra stuff, and everyone's got a mobile phone.
Yeah, that's for sure. Yeah. So what do? You just take heaps and heaps of photos with your mobile phone, stick it in that program, and then you can actually design your 3D whatever it is around those photos, can you?
Yeah, you can create a mesh out of that, and then you can import that into your software, and you might need to scale it a little bit. So if you know the distance between two bolt holes, then you can scale up the whole model based on those measurements, and then you got a 3D model of the whole thing, and it's a lot better than having nothing. And look, I've done it many years ago, and it works like a charm. And sometimes you don't have an option to use a 3D scanner. Sometimes the only option you have is, for whatever the reason is, to use a camera of some description, and it works great. It's just a lot more labour intensive. That's all.
Yeah, because I know Mark Lavelle down in New South Wales there, he's been asking me to 3D print him a caravan, and I haven't got any designs at the moment for a JK Journey Outback. So I'm sorry, Mark, I'll have to run up to Bundaberg, mate, and take a lot of photos, mate, and you might have it within 2030 by the time I'm finished. Yeah.
I think there's a few applications for iPhones and stuff as well.
What's that? Sorry?
I think there's a few applications for the likes of iPhone. I think I've seen an iPhone application. I'm not an iPhone user. I'm an Android user. You can create models using your iPhone because they have inbuilt LiDAR from memory.
Yeah. MW's just asked, mate, what is the best to clean the build plate with, and how often should you clean it?
Oh, okay. So again, this just a lot. I tell you what, a lot of these answers is it depends. Now, if I'm doing, let's say, a PLA print,
Right.
And I've just pulled out a build plate, and I'm not sure what's going on with this build plate. I'll just go and wash it in hot soapy water, dry it off, and make sure I don't touch it, because you don't want oils from your skin going onto the surface of the build plate, and that's it. That's all I use on a textured PEI plate. If I use, let's say, TPU, which is a flexible filament, here's an example of TPU. Is a drink holder I knocked up. So as you can see, it's a flexible filament.
Wow. Yeah.
That sort of stuff, it sticks extremely well to a build plate. So contrary to what you think, a lot of people use glue stick or a liquid glue or a hairspray on their build plates. The reason you primarily use that is so it doesn't stick too well. So when it cools down, you can actually get it off. TPU, like I say, that sticks extremely well. I don't think I'd actually be able to get it off unless I use some sort of release agent, like the bamboo glue I use, or it depends on the build plate and depends on the type of plastic you're using. With ASA, which I primarily print, I'll say wash the plate, hot soapy water, make sure I don't get it. Then I'll wash it down with IPA, which is an alcohol. Mm-hmm. And then after that, then I'll put on the bamboo green glue, just a full coverage over the whole plate. And usually that's good for 10 or 12 prints. I usually let it run for a week, and then I'll wash them off again.
And then you wash it off again, yeah. Because I'm just using PLA at the moment through my Creality K1 thing. But I use the liquid spray glue from Jaycar. And I find I get about 6 prints done on that, and then it's got no more agent left on the build plate. Should I wash that in IPA or with just normal dish soap, mate?
What sort of plate is it? Is it flat or is it textured?
It's a smooth build plate, mate. Just PEI, I think it is, or PIE.
No, a smooth PEI, yep. So just wash him off with soap and water, dry him off, and then give him a go if you want. Look, PLAs, I mean, other than the fact that it can be a bit brittle and it doesn't handle heat very well, it's great stuff to work with. It's easy to print. It doesn't warp. It's just really good stuff to print. Nice and easy. Yes. So and it's forgiving with temperature variations, and you don't need to heat up the build plate. You don't need an enclosed printer to build a lot of heat in there. So it's pretty forgiving. You can get away with a lot with PLA.
Right. Yeah. And mate, what programs out there for slicing, as they say, to finish off your programs, mate? So what slicing programs is there out there to use?
Yep. So for those who don't understand, once you get your model, and it's usually in either STEP or STEP or STP format, or more commonly STL models, then you need to take that into a piece of software called a slicer, and that literally does what it says. It slices it up to suit the printer. So it takes into consideration things like, the type of printer it is, what temperature the particular filament needs, and it creates what's called G code, which is, for those who may have done CNC programming or anything like that, it's a human readable form that tells the printer exactly what to do in each and every step. So it says, okay, so this code means get the build plate up to 100 degrees Celsius. And then once you've done that, then you can move on to the next line. And the next one might be move the print head to this position in space, and so on and so forth. And so well, it depends on the printer again. So my resin printer is an Elegoo printer, and that uses a reasonably proprietary software called ShituBox. Which is great, but it doesn't work for my FDM printers. So for the other FDM, another one for the Prusa fans is Prusa Slicer. So that's a very common one. A lot of them are based on Prusa Slicer. Prusa Slicer is pretty much open source too, so it's a community-driven thing. Orca is probably becoming one of the most common thing because it can not only do Prusas, but it can do the bamboos, and they're all the FDM stuff, all the open source based or closed source based on the open source stuff. It's very, very similar. Like the Bamboo have Bamboo Studio. And if you I've got a copy of Bamboo Studio and Orca on my computer. And I'll tell you what, if I was to open up one and the other, there's barely any difference between the two because they're very, very similar settings and everything. There's a couple of slight differences with the Bamboo Studio to suit the Bamboo printers. Like I can set off multiple prints at the same time, which I can't do in Orca, but pretty much everything's, unless you get into the nuances, it's pretty much all the same.
Pretty much. Now, Phil from Phil's Camping Reviews. G'day, Phil. Hope you're well, mate.
Phil.
Do you use any glue sticks at all, mate? Or does it got to be a particular brand that you got to use, mate?
I've used the Bamboo glue stick on the smooth plates, and I use something I found down at Officeworks. So I couldn't even tell you what brand it is. They all work pretty much the same for me anyway.
Do they? So you can just get like any kids like glue stick, can you, and use that on the build plate?
Anyone I've tried so far, it seems to work fine.
Seems to work fine.
Look, I'm sure there are ones out there that don't work. Just do a bit of Googling and you should be able to get the answer. But the ones I've tried have been okay.
Really good.
But like I said, work out whether you need to put down a glue first. So whether you actually need to do it or not.
Need to use it or not, yeah. So Mrs. G just asked, what's the most interesting thing that you have printed?
Oh, geez, okay. Like I said, I print all sorts of odd things. Sometimes they're one-offs. Excuse me. So this, for instance, if you can see, this is just a basic plate. But this is actually, and I'm using it for parts at the moment, I must confess. Yeah. But that's actually for the turntable for my 3D scanner. So the 3D scanner was, I was having issues with it being black at the time. So I thought, I'll just print up something out of white and make a cover for it. So I did that. Yes. This is a Solid GPS. Anyone heard of those guys? It's a tracker. We seem to be having a problem with Land Cruisers being stolen down here in Victoria. And look, it's primarily the 200 series. They're packing in through the OBD2 ports. And a mate of mine who's part of Lockie Hubs, actually, Matt, got his car stolen from down Essendon Way in about a month and a half ago. And a few people in the club have had their Land Cruiser stolen. So I got the paranoias on, even though I don't have a 200 series. And got a couple of these GPS trackers. The problem is there's no way to mount them. There's no screw holes, as you can see. They're just a basic case. So I thought, what am I going to do about that? And I thought, I know. I've got a 3D printer. I have a solution. So as you can see, there's a couple of screw holes there. Yes. And there's a couple of screw holes there. And I'll put a few diamonds in there so you can get in there and screw them down. Yes. And I'll put a little, it might be hard to see on the video here, but there's a tiny little bump there. Now the bump's there, so when we put it in, it just snaps in and it holds there.
Holds it in there. Right.
So it's things like that. I mean, a couple of mates want them, so I'll print off a few of those things. Other things I've done is Starlink. Starlink's very popular, so a couple of Starlink mounts. There's one I'm working on at the moment. You might have heard of people who are into winching might have heard of Albright, which are a manufacturer, especially the guys into winch racing. Mm-hmm. What I want to do is I want to mount an Anderson plug to my bull bar for not only powering things like my air compressor, but I also want to do things like put in a large enough Anderson plug, SB175, so I can jump start other cars.
Right.
And I also want to integrate one of these things, which is easy as relay to operate this large contactor. So I can turn it on and off without actually using a manual switch. This one senses the alternator, so when the car's running, it turns on. So when that one turns on, I can then turn this on. I thought, well, how am I going to join them? And I thought, I know, I've got a 3D printer.
It's amazing technology. Yeah.
It's got a few odd little, curves and whatnot. And I thought, well, I can make something up, and then I'll have a solution. And there you go. So that will that'll, if you can see in the camera there, so that'll bolt to the firewalls. This is made of a plastic called ASA. So that's good to 90 degrees Celsius or so. So that'll be fine in the engine bay. And now I don't have to find extra mounts. I can just mount the one thing, and it's all integrated together.
All integrated together, yeah. Now, MW's just asking, please explain to the ins and the outs of supports when printing the model with the PLA. I'm experiencing with using opted builds into Creality, such as tree supports and grids, but any guidance on supports?
Okay. Supports. Look, it depends. Starting off with it depends a lot, don't I? It depends on the model and which is the best. Sometimes I use grid, sometimes I use tree. I actually have a fail print over here I should be able to bring in.
Yes.
So this is an Infinity Cube, and you can see this one here has got tree supports.
Yes.
So-called because they look like a tree.
Right.
Now, what I've done, and it might be a little bit hard to see on the camera there, is you can see white under the side here.
Right.
Now, the reason I do that is I use a different material called HIPS. It doesn't stick well to ASA. This is an ASA print, just because I had ASA in the machine at the time. You can equally use PLA and PETG, and what it is it's an interface filament. So just one layer in between your supports. So here's your model, say, and here's your support, and just one layer in between the two is this other material. So in this case, it's HIPS. But if you're printing in PLA, you can use PETG as your interface between the supports and the model, and it makes it really easy to get rid of your supports. They just literally click off, and it leaves you with it leaves you with a lot cleaner surface than regular support. So if you do have a machine that's able to take multiple different types of filaments, the likes of I think the Creality K2 do it, as well as a lot of the Bamboo machines. By all means, investigate having an interference layer in between your supports and your model, and your supports will come off a lot easier and a lot cleaner. Right. But again, it depends on the model. If you've got a large flat surface, you probably want to use grid supports. If you want to support a screw hole halfway up the model, well, you probably want to use tree supports for that. It depends.
Yeah. So with the tree supports and stuff like that, is there any filament that chemically reacts with other filaments, such as, like, say, if you're doing a ABA resin print, and then you use a PLA as your tree support? Is there anything like that has a chemical reaction with other filaments when you're doing stuff like that?
I know, well, with resin prints, you usually, using hobby standard machines, because it's all in the same vat, you're pretty much stuck with having to use supports that are made of the same material, which is unfortunate. But with the likes of FDM, like the Bamboo printers or whatever, you can get water dissolvable supports. Like PVA. I use supports so at the bottom of this one, as you can see, I'm not sure if you can see the surface there. What I did there was I used PLA as support. So this is all TPU, obviously, so the whole thing is TPU. Right. So the bottom layer was TPU, and then there was a layer in between that surface there. If we can get in the camera there we go. In between that surface and the TPU support filament, and this was all done in grid, was a layer of PLA. Right. And then we got a little crevice in there as well for the cans. And again, there was another layer of PLA. So definitely have a look into multi-material. I haven't seen any that you just need to work out. Like if some of them stick really well to others, like if you try to put ABS and ASA together, it's going to stick really well, and you'll never get the sports apart. So you need to find materials that don't stick well together, like ASA and HIPS or TPU and PLA.
Yeah. So what is actually HIPS, mate?
It's just another material. So it's just another. It's not a really common one. And look, because I'm only using it as an interface between the two, I don't use very much at all. I probably use 1 kilogram to every 100 kilograms of normal filament.
Yeah. So Phil's just asking here, can that be done with the Creality 1K Max in regards to supports?
They've got the multi-material system, have they, for the Creality K1? I'm not overly familiar with that printer. I think they do. Right. No, they're only on the K2. I'm not sure.
Only on the K2, is it?
Right. I'm not sure. What printer have you got there?
He's got the K1 Max like I've got, Simon.
Can you get the multi-material thing on top?
Yes. So you can use all different types of materials, yeah.
Primarily people use it for multicolour, so they can, have a black eyeball and a purple dragon or something like that on Flexi, but which is great. But it also comes in really handy for the multi-material stuff. And
if you're probably going to bring up the AFS for the K1 next year, but they haven't actually got all up and working properly yet for all of that. Yes.
I must confess, with the FDM stuff, I've become a bit of a bamboo fanboy. I suppose you'd call me. And I've got a couple of those bamboos in the background there, and I'm looking at the third one. So they're just great printers. They really are.
Yeah. Now, Phil's just asked, what brand of filaments would you use, Simon? What's your favourite brand to run to?
Look, for ASA, I'm currently using Sediment, which is a bloke in New South Wales. Aerarium down here in Victoria, he's a local manufacturer too, which is good. And I'll use the likes of eSun and all the usual people, but primarily for the engineering stuff, I'm using, especially the ASA, I'm using Sediment.
Sediment, yeah. And what brand should you stay away from, Simon, within filaments and resins, mate?
Oh, look, I really haven't come across too many bad ones, to be honest. Look, I've come across ones that needed some fine tuning because they're far and away different from the normal filaments that I use. I grabbed some Fuss Rock on recommendation of a mate of mine, Tim. And that worked fine, but I had to dial it in first. So I did a print with it and I went, oh, geez, have a look, this looks like rubbish. And it was under extruded and the temperature was wrong. And I just needed to sit down, spend a couple of hours dialing in the filament, and then it printed just as well as the Sediment stuff for me.
Right. And now, guys, is there anyone in the comments there that would like to ask Simon any questions? Feel free, just click on that link if you would like to jump on and talk to Simon, and or you're quite welcome to put it in the comments. If anyone would like to ask Simon any questions, feel free, hit that link or ask him in the comments there. So yeah, and with your 3D printing, mate. Now you can you show us a little bit like behind with the CAD programs on how to quickly create something?
Sure. Okay. So now I know a lot of people getting intimidated by CAD programs, especially don't have any sort of engineering type background. But really, if you can slice a model in a slicer, you can probably do basic CAD stuff. So what we'll do is we'll fire up Underhill. No, I haven't built a Voron yet. I'm actually thinking about the Rat Rig, the 500 by 500.
Right.
And I'll tell you what, if I can swing that one past the Minister of War and Finance, we might be talking about one of those just behind me as well. All right, so what we'll do is we'll jump into SolidWorks.
Right.
I'll just bring that up now. So I use the Maker edition of SolidWorks.
Right.
And I think that should come onto the screen now. Okay, all right. So this is your basic screen of SolidWorks, and as you can see, we got front plane, top plane, right plane. So that's the various sizes. Down here, we'll just swap that to millimeters. Okay, all right. Now, what we do is we'll select the plane. So we'll say the top plane, and this is what's called sketch-based software. So we'll just sketch. We'll start up from the center, so it's the origin. You want to start from the origin there, and we'll make it square. Okay, and let's, for instance, let's say we'll make it 10 centimeters. So we'll just put in the parameter 10 centimeters there, and 10 centimeters there. Now we've got a 10 by 10 circle. I'll make that a little bit bigger. Oh, sorry, square. Right now, when you're using CAD software, well, this type anyway, what you do is you extrude or extrude cut most of the time. So we'll click on the features here and we'll go to extrude, and literally those who are familiar with any sort of industrial process will be familiar with extrusion. So we're extruding now, and we're just going to move that little thing there. So that says 10 millimeters. So we'll end up with a cube. So if I press on the click there we go. Now we got a 10 centimeter by 10 millimeter, cube. Okay, so that's just a basic 10 mil by 10 mil. Lady Smurf, is this free software? This one's actually in the maker version, and they charge $24 US per year. If you want a completely free version of this sort of software that you don't have to pay for at all, have a look at Fusion 360. That's free for personal use. Right. And that's probably your best free software that most communities support. So now, let's say we want to cut a hole in it. Let's say we want to cut a round hole in it. So what we can do is we can go into the center of it. I'll just spin it around. So we can just look at the, and we'll see if we can get into the center there. And let's say we'll draw a hole. And now we'll go to features and we'll go extrude cut. And now we can select how far we want to go through. So let's make it a little bit more. Let's make it 15 millimeters. And you'll be able to see it popping out the other side by 5 millimeters.
Oh, wow.
So you can make it 20 millimeters if you want. Now, that's obviously going into free space. So it's not going to cut anything more than what you have here. But let's say if you only wanted it 5 millimeters, well, now it's only going to cut a depth into the halfway down into the hole. So let's make it 5 millimeters.
Right.
And there you go. So now you've got a hole in there, and let's go into that hole, and let's sketch another thing on that hole, and let's make it. Well, if we reference the outside, we'll get the center there, and let's make that. Oh, I don't know. It goes by radius, so let's make that 2 mil radius. Let's make it a bit smaller. Let's make it 1.5. Okay, and then so we got that there, and we can go to features, and we can extrude cut again. Now by default, it's going to go the extra 5 millimeters, so that gets us right through the other side.
Wow!
All right, so now we've just created a basic shape. Now you can imagine this is, let's say you've got a Allen key bolt, and you want it flush with this surface here. You've now got a stepped hole that will take that Allen key bolt, and flush to the surface right through the other side. So it's just an extension upon all that stuff. Now you can do things like, let's say you want to fillet this edge. You want to round that edge. So we can just fillet off that edge. 10 millimeters, bit big. Let's make it 2 millimeters. Oh, let's make it 1 millimeter. Bit big, is it? Still. Oh.
There you go.
Right, let's make it.
So that just gives it a bit of a flange for the bolt to sit on top?
Yeah, we should be able to get a fillet on there. Maybe we need a chamfer. Edge 1. Of course, it's not working for me now. But I'm trying to demonstrate it. All right. Well, that's not working for me.
You're under pressure, you're trying to do something, right?
Yeah. Oh, yeah. It's inevitable. Anyway, so on the larger models, you can fillet, you can chamfer. It's not going to beat me. I'm going to put a chamfer on there somewhere.
Mm-hmm.
Let's try a chamfer in there, and we'll make it a lot smaller. No, it's not going to work for me. I'm doing something wrong. But anyway, so what you can do is you can do basic stuff like that. If you've decided it's, let's say, too long, and you want to cut it down a bit, well, that's nice and easy. So all we do, we can actually make it so you can see through it. Right now you can see the inside of it as well.
Yeah.
And let's draw a sketch on the side here. And we'll make that, let's say, 2.5. And then continue on. So now we've created a sketch on the outside. We'll go back to the normal view so you can see it a bit better.
Right.
And let's say we want to extrude cut that. So extrude cut that. And let's say we'll make it 2.5 millimeters. So it's going to go halfway through that hole. Let's say it's mating up to something. And there you go. That's it.
Wow.
So
that's fantastic.
It's just basically, it gets more and more involved than that. And you can do a lot more involved models, but it's basically you extrude stuff and then you cut into it. And you can do it on curved surfaces, and you can follow, you can make an odd shape and follow a line that you set and bits and pieces like that. But that's the basics of it anyway.
That's the basics of them. Yeah. No, that's fantastic, mate. It's incredible. You can actually, Sorry, Simon.
I'll just stop sharing that screen.
That's all right. Yeah, it's incredible what you can actually do with a 3D printer. Like we were discussing a little bit earlier, it's incredible how you can actually design something within minutes. You're holding it in your hands, aren't you? And it's a tremendous feeling that you've actually had a thought, designed it, and there you've got it. You've created it, isn't it? It's...
you can do all sorts of strange things. Actually, I got this cup for Christmas, a Yeti cup, and of course it doesn't fit in the work truck, so I had to make up an adapter for it to fit in the work truck, and I designed it in about 15 minutes or so, with a hole cut for the side there for the handle, and sent it to the printer overnight. Created out of ASA because it's going to live inside a vehicle, so it'll experience, on a hot day when it's locked up, might be 50 degrees or so in there. So I used ASA for that, and Bob's your uncle. And the next morning I pulled it out of the printer and threw it in the work truck.
Wow. Now Phil's just jumped in. G'day, Phil. Phil's from Phil's Canton Review. How you going, mate?
I didn't know it was on. How you going? Hello, Simon. How are you? And
good, Phil.
Everyone. How are you, all?
Yeah, good. Thank you, mate. Did you have a good Christmas?
Yeah, I did. It's been a very busy Christmas, spending with the family. Awfully hot, as you're aware, Terry, up this way. So
yes,
give me winter any day. I don't like summer, but that's okay. I'm surviving, sitting in the aircon, playing around with my 3D printers, actually, now.
Yeah. So, what question would you like to ask Simon, Phil?
I don't know. He's got a wealth of knowledge, hasn't he? I've pretty much covered all the questions I wanted to know. I mean, regards to the glue, I wasn't sure whether there was a special glue stick that you had to use for when you're printing with PETG. I've only just started using PETG.
Okay,
Yeah, and I'm actually right now printing a 1/220 scale of the HMS Titanic ship. I don't know if you can see me. It's right beside here. It's probably about 75% complete, and it's 125 centimeters long.
Oh, jeez.
And that's what I'm doing right now, actually. I've printed some of the... I'm using a combination. I've got two printers. I've got a filament, which is a K1 Max. You could probably see it. And I've got a Elegoo Saturn 4 Ultra, whatever.
Okay.
Yeah, resin printer. So I'm printing all the railings for the Titanic. If you see the fine details in that.
Yeah, well, that's the advantage of resin. It's great for that sort of stuff.
Yes, yes. You definitely need a resin if you want to go down to details like that. So it's quite amazing. It's a huge, huge learning curve. Oh my gosh, how many times I just about ripped my hair out, man, just learning how. Because mate, I do things the hard way, eh? When it starts out, I started out with resin printing, and then went on to filament printing. And oh
Yep,
boy, filament is just so much easier, man.
it is.
But
Yeah.
resin, mate, stuff like this, the fine details that I'm doing on this thing here, you just cannot do with a filament.
With
You
the
know,
No,
filament.
no, you
Hey,
can't. No,
can you
it
show
does
us
have a
the,
I
resin.
mean, I've got some. I've got some. So I'm building a model railway set. So, and this is the reason why I got into. This is the sole reason, guys. What you see here, this is the reason why I got into 3D printing, because I'm going back into my childhood days and acting like a kid now. I'm playing with trains and
that
stuff.
by all? Yes. Yes.
And so I'm building my own model railway set, right? And I started buying all the scale, online shops like, stuff like this and all that. And I'm sitting there because I'm building a pretty big setup. And I bought about 4 or 5 houses, and it cost me about $300-400. And I'm thinking, this is way too dear. It's going to cost me
It is.
thousands to do that. And then I thought, mate, it's going to be cheaper if I buy a printer and make my own. So
Yep.
Yeah.
I went and bought the printer. And
Mm-hmm.
this is some of my first stuff that I've done. This is with the resin printing. So you can see the balustrade and all that fine detail there.
Mm-hmm.
Now, in saying that, I am mighty impressed with these Creality K1 Maxes.
Mm-hmm.
Um, they can't do anything fine details like this, but I'll tell you what, you set it up right, it's not far off, eh? It's not far off. It's
It's pretty
amazing.
close.
It's
Yeah.
a lot, mate, it's a lot better than I thought it would be. Put it that
Mm.
way. And certainly a lot easier
Yes.
learning process. But,
Mm-hmm.
this is another one here.
Right.
So this is why I've gone into 3D printing. And mate,
Mm.
I love it. I love it. It's a great hobby. And mate, I've just gone into crazy stuff and now. I mean, look at this here. Excuse the mess in the background. Mate, that's the
No, you're right.
Titanic. I've 3D printed all of that. You know, all the
That's
little
that's absolutely massive.
Isn't it? Yeah.
fine details on that. There's like nearly 300 parts in that.
Wow.
So, and I'm enjoying it. It's fun. It's fun.
Mm.
It's a really good hobby to build things to display. I'm going to display that.
Yeah. Yeah.
This is the third Titanic that I built. This is the third one.
Yeah.
So yeah, no, it's just awesome. But I'm kind of glad, 3D printing is something that I was interested in for quite some time.
Yeah.
Me, Terry, we spoke about it in the past.
Mm-hmm.
But now I've
I'll
got a
just pause
really
you
good
there for a
excuse.
second, Phil.
Yeah,
We've just lost Simon. I'll just bring Simon back to the stage, mate. Hang on a sec.
yeah, okay.
Sorry, I think I
There he
clicked the
is.
wrong button there.
We lost you there, Simon. Sorry, mate.
I was trying to increase the size of the screen so I could have a better look at this Titanic, and I think I pressed the wrong button. Sorry about that.
Yeah, that's all right, mate. Yeah, you might just have to bring your camera back on, mate.
Okay, should be back on in a second.
Yeah,
It says my camera's working.
it says your camera's. I might remove you
I
and
don't
I'll
know.
get you to jump back in, mate.
I
Okay,
don't know
no.
if you can see that. I don't know if you guys can see that.
Hang on a sec, Phil. I'll see if I can bring you in. No, wrong one.
you can see the folks will be able to have a look at some of the details. There's the winch.
Yeah, can't do it, Bill. Sorry, mate.
What happened?
Don't know. We tried to enlarge it, but I can't figure it out. So yeah, I'll try and bring Simon
all
back
right.
in again.
I'm only on my phone, guys. So.
Oh, okay. Yeah, we might leave you
Yeah.
to it there, Bill, and bring Simon back in. And I know Landy's got a question for Simon. Yeah. So thanks for joining us, Phil. And yeah,
That's all right.
always lovely to have you on, mate. So yeah, take care. Yeah.
Yep. No worries.
Thanks, Phil. Okay, we got
We
me
still
back
haven't
now.
got you on camera there, mate. So he's on. Oh, I can't
Apparently,
see
I'm
him on
on
my
the show. Okay.
Yeah,
It tells me I'm in the
Hey,
show.
Landy, yeah, Landy would like to know, Simon, what filaments plastic is the best for UV?
Okay, so for the FDMs, you want something that's UV resistant. I'd probably go with ASA.
Right.
Problem is, you do need really an enclosed printer for ASA. It doesn't work very well for non-enclosed printers. If you don't have an enclosed printer, I'd probably look at PETG. Would be
Right,
probably your
okay.
second best bet. Though ASA is a lot better than PETG for outdoor and UV use.
Your use, yeah. Now, Australian camping and four-wheel drive, Simon, if you wanted a good bamboo printer, which one would you recommend, given that I've considered printing products for sales?
Okay, so you're probably looking at ROI, some sort of return on investment on that. Well, assuming you want to be doing engineering type, again, it depends. If you're just printing PLA and you're printing toys and stuff, any of the unenclosed printers will be fine for use. But I'm more familiar with the engineering type filaments where you need an enclosed printer so you can get it nice and warm in there. I usually print at about 60 degrees Celsius for ASA or somewhere in there, 65.
Right.
I got a, which you probably can't see in the background there. There we go. Move to the side. You can see the one on this side is wrapped. There's a wrap on there, an igloo wrap to keep the temperatures up.
Yeah.
So I like the XC1. Look, the was it P1P? P1P, I think is it's almost identical. It doesn't have the hardened extruder gears. It doesn't have the hardened nozzle, though you can replace both of those. But the screen is trash. So, but in comparison with the XC1, you can, of course, use the app on your mobile phone, which is great. The app works fine. I know some people who it is a lot. The P1P is $500 cheaper or whatever it is. If you're going to be using the app, just as that, you miss out on a decent camera. So if you're doing a lot of remote monitoring with a P1P, the camera's rubbish in comparison with the XC1. Also doesn't have the LiDAR as well. So spaghetti failures and stuff like that.
Right.
If you were just getting the one, I'd get the XC1. If I was getting multiples and could endure the occasional failure because of no LiDAR or anything like that, I'll probably go for the P1P because you get a return on investment faster.
Right. I see. Yeah. And Landy's asked, how long does the filament last before it gets affected by the moisture in the air, mate?
Okay. Yeah. No. Look, it depends. Just that's the theme of the night, isn't it? It depends on the humidity. So of the atmosphere around. I mean, in Melbourne, I think it was sitting at about 50% humidity. And 20-something degrees is usually what I get in the printing room here in the home office. And it's not too bad. The main filaments I need to watch out for is PETG and especially TPU, and very occasionally when I print the likes of nylon or something.
So do you think it's important then too, mate, to have a stable environment for printing?
The more stable, the better. And usually, like I say, with the PLAs, it's not a big issue, but with the engineering filaments, it is.
Yeah. And Rob's just also asked, he's thinking about going for the X1C. What's your thoughts on that, mate?
Well, I've got two behind me.
Yep. So
I bought one and then liked it so much I bought a second one. They've become an appliance now as opposed to a hobby. I mean, I've had my deal of Crealities and all that sort of stuff back in the day, Enders and whatnot. But even when I'm not at home, if I'm reprinting something and the build plate's clear, I'll send a print from my phone using the Bamboo Handy app to the printer, and I won't even look at the camera half the time. I'll just expect it when I get home or whatever that it'll be finished and it'll be ready to take off the build plate. They're that reliable. They really are. They're great.
Yeah, it's incredible because I've got the K1 Max as well, and I've got the app on the mobile phone. And when I was down the shop there shopping with Robin, and it's incredible. You can actually run your 3D printer being away, because everything's all Wi-Fi, and you've got the AI camera and the normal camera in it. So it's totally safe if there's a stuff up within the print, it just automatically shuts down. That's the beauty and the safeties about the K1s. And just to be able to see it down away from home and making sure that your print's actually printing correctly is absolutely phenomenal. And to be able to program it away from home is fantastic, as long as there's nothing on the build plate as well, isn't it, Simon? It's
and look, I've asked a good lady wife once or twice to clear off a build plate for me, and whip off the extrusion lines at the front there, and then I'll say thanks very much, and I'll heat it up. Well, using engineering filaments, you want it heated up a bit. Heat it up for half an hour, and then send another print to it.
Yeah.
I don't even look at the first layer. It's just
yeah. So Landy says, what services do you need to do a 3D print and how often?
Okay. So look, there is a Bamboo did put out a one that you're supposed to be following, and I've actually set up because I'm a pedant. I've set up a Trello board that reminds me that I should be, cleaning the LiDAR camera. I should be tensioning the belts and all that sort of stuff. And I more or less do that with those printers. Replace the carbon air filters and all that sort of stuff. That on the other side of the coin, I've got a mate of mine who's got an XC1 and two P1Ps, and he builds batteries for a living. High quality aftermarket lithium ion phosphate batteries for caravans, high-end builds, Kendrons and all that sort of stuff. And he does quite a few 3D printed components for inside the batteries.
Wow.
As well as some other componentry for the likes of Victron gear and whatnot. LifeTech. If you're after a battery, have a look at LifeTech. He's a good bloke. And he builds a hell of a battery. Anyway, and he tells me he pretty much doesn't do maintenance at all, and he doesn't have issues.
Yep.
He's too busy building batteries to do maintenance. So he just LifeTech, that's the one, handcrafted by Terry G. Thanks, mate. So have I think it's TEK from memory. Don't quote me on that.
Is it? Oh, sorry, mate.
I'm sure if you Google it, it'll come up. It'll fix the spelling. He spelled it unusually. But have a look at those batteries, and he does a lot of 3D printed stuff inside them, and he pretty much does no maintenance and just keeps ripping out those parts. I don't know. He's definitely got thousands of hours more than I do on his printers, and they just keep pumping out the parts.
Yeah. MW is asked, with storms around, mate, is there a power outage and your printer something with the build, your printer's able to salvage when the power comes back? We're in Queensland and storms every night is common.
Okay, so I run those printers through a UPS, or uninterruptible power supply, to EcoFlow unit.
Right.
I'm using this word a lot tonight. It depends. So I can get 2 or 3 hours running off the EcoFlow, not a problem. And it's not often down here in Melbourne that we actually get a power outage longer than that.
Right. Yes.
The problem I get I have had it previously. Is the EcoFlow ran out and the print was just sitting there.
Yeah.
You can restart prints, and that's not an issue, but it depends on how far the build plate cools down.
Right.
So in my case, because I'm running primarily engineering filaments, when they get down to 30, 40 degrees, the print just pops off.
Yeah, gee.
So I need to keep the build blade hot. If you're using something like a tack plate and PLA, you're probably fine for days.
Right.
I've suspended prints when for instance, I suspended a print because I ran out of filament and I forgot to put a new filament in there. And it was just sitting there on a hot build plate all day, 10 or 12 hours until I got home. And then I put a new roll of filament in there and kept printing. So that's not an issue. It's just, depends on the type of filament you're running and how hot you need to run the build plate.
And how hot, yeah. Now, Landy's asked, what paints do you use after a print's done, mate?
Well, you're probably looking at the wrong bloke for that. I don't make models.
Models, yeah.
What do you? What do you guys do?
Yeah, I just use water-based acrylic, Landy. For a primer, I put a primer on first, which is a plastic primer, just in a spray can. You can get it at Super Cheap. You can get it at Bunnings and all like that. Stay away from solvent base if you're using PLA, because if you spray with a solvent base like Rust-Oleum or just like a cheap one that you get from Bunnings for like say $4 or $6. Some of the solvents actually have a chemical reaction with PLA or PTG or anything like that. So it's all trial and error, really. But if you stick to the water base, acid free, you're laughing, mate. So, yeah.
Okay, beautiful.
So here's some of the work that I've done here. And I just use water-based paint with that, just normal standard acrylic. And, I haven't had any dramas or anything like that. There was one of the prints that I did, I used a spray can because I'm only just running PLA with mine. Now, you can actually see the bottom of the building. It's actually warped, and that's from the solvents actually in the print has actually had a chemical reaction and made that warp. So yeah, best to stay away from those chemical side and just stick with your water base. With I suppose with all filaments really, because it depends. Like some filaments too also have like oils in them that actually lubricates all the gearing for the feeders and all like that. And sometimes with the oils within the prints can also have a chemical reaction with your paints as well, so you got to be careful with that. So, yeah, all trial and error, mate. Yeah.
Did he? Yeah, I to be honest, I haven't painted a single print so far.
Oh, so,
I haven't even printed a Benchy.
Wow, I've done one. Yeah.
Which seems to be the first print for just about everybody, except for me. I've never printed a Benchy. I'll have to do that one day.
Yes. My first print was a scraper because my first printer was the Creality Ender V3 SE model. Now, those were basic machines, those ones. And I did a YouTube video on it, guys. And it's actually a pretty amazing machine. Is the only problem with my first printer that I had, than the K1, was the build size quality. I wanted to do bigger prints. That's one of the reasons why I went to the K1 Max like Phil did. But the SE model for a $250 machine, Simon, outstanding. It probably beats some of the really expensive ones out there.
Yeah, that's the Bamboo machines. I mean, for all the positive attributes they have, and there are a lot. Build volume's not big. So
yes.
They're 256 by 256 by 256, but there's a little cutout in the corner which you can't use. And then if you also have multi-material, you'll need a purge tower as well, so you have to take that out as well. So it all cuts into your build volume, unfortunately.
Yeah. So in the future, Simon, have you ever any thought maybe to designing your own 3D printer?
Oh, look, I haven't as yet. I might look at a rat rig later on.
Right.
Just for that's a pretty much a DIY kit.
Mhm.
Other than that, and only because of the build volume, look, it's rumored that there's a new bamboo machine coming out,
Right.
much larger
Mhm.
than other ones. So we'll see.
Yes, yeah. Now, Rob's just asked, are all the plastics food safe and drink safe?
That's a very good question. I don't know the answer to that one.
Right.
I haven't really looked into it. Don't know.
Oh, okay, yeah. I suppose it would be because PLA is what they normally make drink bottles and all like that out of, Rob. So PLA I know is pretty well food safe.
Coke
PETG,
bottles and stuff are PET. PET.
are they? So yeah, there you go. So PETG would be, yeah, for your drink bottles, mate. So I believe that would be safe. Landy's saying, I believe not. Oh, okay. Yeah, so it depends. You might really have to do your research on that, mate, and just find out
Yeah, I've
which
never
is safe
really
for a food product and which isn't.
created
So,
any drink receptacles or anything like that to look into it. So I don't know.
yeah. So NW just asked, what printing's everyone printing right now? I'm printing the thing from the Adams family. So, yeah, my printer's actually turned off, MW. Yeah, I haven't done a print since last night. So I thought I'd better turn it off. That way you don't hear any of the noise from the fans or anything like that, mate. So,
Yeah, both mine are
yeah,
turned off at the moment as well. So
mate.
what I'll be starting right after this one is I'm still working on the other half to this.
Yes.
So that's the bit that mounts to the bull bar. That'll be going onto one printer. I think the other printer,
Right.
I'm making something. Yours hasn't stopped since Christmas Day. Yeah, mine pretty much.
Yeah.
I did an
G'day,
average.
Yes.
I did an average once for my XC1, the original one. Actually, you can see in the background over there.
Right.
Alpha, as I like to call it. And that averaged
Mhm.
14 hours a day. It was printing
Wow.
7 days a week.
Yeah, that's
So,
incredible.
yeah,
I was
it
printing
cranks through.
Yeah, I was printing the station for my model railway, and I know that the roof took 29 hours and 30 minutes just to print the roof. And that was on my first printer. And I'm glad I did buy the second one because it's 3 times the speed of my first one. Jack Turtle's just arrived. G'day, Jack. Hope you and Mrs. T has had a fantastic Christmas.
G'day, Jack.
Yeah. So this is my latest print, guys. I'll show you this one here. This is what they actually call the most annoying gift box, and which was my latest print. And that one there, it's got 260 screws that actually goes into it, and it has 4 different types of screws. Now, I believe there's 90 reverse screws that actually go into it and 10 screws that'll just sit there and spin and you can't get out. So what you actually put into that is like a gift card or something small, and you give that to someone, and it's absolutely a funny thing to try and watch them get into that, trying to get out 260 screws to get to their little prize. Now, Simon, you actually gave one to a friend of yours, mate. Tell us a little bit about the story behind that one, mate.
So at Christmas, we run a Kris Kringle because we breed like rabbits here, obviously, and there's too many of us. Anyway, I pulled the son-in-law out of that, one of the son-in-laws, and gift cards, I think, are a bit of a cop-out when it comes to Kris Kringle, and I'm trying to discourage people from actually selecting gift cards. So what I thought I'd do I got into SolidWorks and I designed a print. So what it was is made out of TPU, which is again this flexible filament, but it's clear. I had some clear stuff, and I made a complete case that could just fit a gift card in. And just before
Wow.
it pulled the top over and printed the top over, I paused the print. Oh, you can do that in the slicer. I inserted the gift card and then I press resume. So then the gift card is locked inside the TPU print.
Into it. Wow.
And hopefully, Justin, if you're watching, mate,
Yeah.
don't select the gift card next year, mate. Don't select the gift card next year. I believe it was gotten into there by using a hacksaw.
Excellent. Incredible. Yeah. Yeah. Fantastic. Well, Simon, thank you very much for joining us tonight. Yeah, it's been an absolutely privilege having you on the show tonight, mate.
Oh, thanks for inviting me, mate.
Yeah, thank you for teaching us everything virtually about 3D printing. Mate, if anyone would like to ask any more questions, now's probably the time to do it quickly. Has anyone got any more questions? We'll just wait quickly. Because I know it's getting fairly late down there in Victoria, or as they say, Mexican land. So, yeah.
No worries, MW. No problem.
Yeah.
Well,
so thank you.
The only dumb question is one you don't ask, of course.
Mm-hmm.
So if you've got any questions, pop them in the comment section. We'll have a look at them.
Yeah, for sure. Yeah. So what's your next print going to be, mate?
At the moment, I'm a little bit of a Victron fanboy as well.
Are you?
So yeah, with the DC electronics and stuff, I like the Victron gear. So I'm making up. There's this thing called a distributor. The Victron distributor is part of their Link system, and it could use some improvements. So I'm doing a little bit of electronics behind it, so it actually reports blown fuses in there, and also I want to make a switch off to the side. A lot of people are doing that at the moment, but it's exposed, and I want to make a bit of an integrated solution for it. So that's the one I'm currently working on.
Yeah, fantastic. Yeah. All right then, Simon. Well, thank you very much for coming on tonight.
Thanks for having me, mate. Much appreciated.
Having you on, mate. And if anyone's got any questions or anything like that, leave them down in the comments below in this video. I'd love to hear from each and every one of you, and I'll pass all your questions on to Simon. And yes, thanks heaps, mate, for tuning in, and we'll catch us all again next time. So stay safe and take care, and remember, make it yourself. Cheers, guys. Take care.
Thanks, guys. See you next time.
End stream.
Stream's ended? Okay.